Hi, welcome back. Today we're going to take a look at the second derivative test. This is again an application of concavity. So that's what we're going to be looking at today, an application of concavity. And before we start, let's review our first derivative rules. So if we're given the graph of a derivative, which we are told right here, we know that if we're above the x-axis, we know that the derivative is going to be positive. Below the x-axis, that's where the derivative is negative, and our critical numbers, or where the derivative is 0, is on the x-axis itself. So the very first question we're being asked here is to find what intervals is the function increasing or decreasing. This is our first derivative test, or where we are going to use our sign charts. So to begin, let's go into our sign chart down here. I need to find my critical numbers. Where is the derivative? Sorry, not the second derivative this time. Where is the first derivative equal to 0 or d and e? And I can get that pretty easily here. This is the graph of my derivative, so it's just going to be where it crosses on the x-axis. And that's going to give us -3, 0, 2, and 3. When we do our sign chart, it looks like -3 is actually an endpoint. 0, 2, and 3, and then it looks like it goes on forever. So here's our first derivative, and here's how it's applying to our function. We're looking for the signs, so where are we above and below the x-axis? And between -3 and 0, we're above, so we say that we are positive and that the function is increasing. Between 0 and 2, we're below the x-axis, so it's negative, which means at that point the function is decreasing. And between 2 and 3, we're also below the x-axis, so we also know we are decreasing. And after 3, we are above the x-axis, so we are increasing in value. So we can answer the question, where is the function increasing and decreasing? So we can answer that. F is increasing, and we're going to say the domains on the following domains, -3 to 0, or it looks from 3 to infinity. And that is because our derivative is positive. Now again, I always prefer soft brackets. It's always a debate, soft brackets or hard brackets. I do always tend to prefer the soft brackets. For the next one, F is decreasing, and we can name those domains. Where is the slope negative? That looks between 0 and 2 and 2 and 3. Be careful, don't go from 0 to 3. We actually stop at 2. So we go from 0 to 3, or, whoops, I just said don't do that, and I did that. So 0 to 2, or 2 to 3. And that is because our derivative here is less than 0. Our next question, now for part 2, says, where do we have a relative maximum and a relative minimum? Well, remember, a maximum says our derivative is going to go from positive to negative, and for a minimum, the derivative goes from negative to a positive. So we can take a look here at, looks like at 0 we have a maximum because we're going up and then down, and at 3 we have a minimum, we're going down and up. So we can say F has a relative maximum, we're going to spell it all the way out, a relative maximum at x equals 0, and that is because the derivative goes from positive to negative. And then we can say F has a relative minimum at x equals 3, because we're going down and then up, because the derivative goes from negative to positive. Very easy to do. All right, so now let's say we're given the graph of the second derivative. Now remember, the second derivative gives us concavity. Sugar gives us cavities. Second derivative gives us concavity. And if this is a graph of my concavity, we know that we are going to be concave up the second derivative is positive above the x-axis, and the second derivative is negative or concave down below. So concave up above, concave down below. We are going to find out where the function is concave up and do we have any points of inflection. So we are going to use our sign charts again. So the first thing we have to do is find out where our possible points of inflection are. And these are where the second derivative is 0 or d and e. And I can get that pretty easily. Again, this is my second derivative, so it's going to be word processed on the x-axis. And that's going to give us -3, -1, 2, and 3. And if we do our sign charts, it looks like in this case they both go on forever. So we got -3, -1, 1, 2, and 3. And we're looking, are we above or below again? We're just looking at the signs here. So before -3, we're below, so we're going to say it's concave down. Between -3 and -1, we're above, so it's concave up. Next one, concave up as well, because we're still above the x-axis. Negative, so we're concave down. And then positive, so we're concave up. 1 was not a critical possible point of inflection, so I'm going to get rid of that one here. So I'm going to start this one over here. I don't know why I did that, but 1 was not one of my possibilities, so I did mess up, so I'm going to go and fix that real quick with us. It's okay to make mistakes. I just made a big one. -3, -1, 2, and 3. There we go. And again, before -3 we're below, so it's concave down. Between -3 and -1 it's positive, so it's going to be concave up. We're above between -1 and 2 as well, so also concave up. Between 2 and 3 it's negative, we're below, and then positive, we're concave up here. There we go, that looks a lot better. So where are we concave up? So we can say F is concave up on the following domains, -3 to -1, or -1 to 2, we're going to take a break there, or from 3 to infinity, and that is because our second derivative is positive. Where's our points of inflection? Remember, this is where concavity changes, so I can get that pretty easily. Points of inflection are going to be there are POIs at x equals -3, it changes. Be careful, -1 was a possible, but notice it goes from positive to positive, so concave up to concave up, so there's no change there, so I'm not going to count that one. 2 and 3, and that is because our second derivative, 1, and let's write it this way, the other way, because 1, the second derivative is 0 or d and e, and 2, the big one, the second derivative, must change signs. It changes signs. And there's our answer right there. All right. Hope you enjoyed this review, and we'll go join us for part 2. We'll take a look at we'll start taking a look at the second derivative test. See you then.